You want this? Our fourth speaker, Vikash Kadati, CEO of Godel Space. Vikash is leveraging AI-powered geospatial intelligence, analyze satellite imagery, and provide real-time climate and defense insights. His work bridges space technology, sustainability, and AI-driven environmental monitoring. Let's give a warm welcome to Vikash Kadati.
Can you hear me? Is there no present over here? Say it again. I thought this was a present over here, but
Click like your click the full screen right there.
yeah. But then all right. First of all, thanks to Vikram. I met him at one of the conferences, and he asked me to just present my journey, discuss my journey with you. So thanks to Vikram and his team. I just want to discuss what we are doing at Godel Space. And what if I told you that the most important decisions today on the Earth are being taken from the space, and from climate change to monitoring trade, from space debris tracking. Everything is being tracked from the space, and economies are being impacted. That's at Godel Space, we are trying to capture a small market in this particular segment. And my intent is to use AI and satellite imagery data to understand patterns in this industry and provide some insights over that imagery. So again, my name is Vikash. I'm the founder of Godel Space. And over the course of the next 15 minutes, my intent is to talk about my journey as to how I came here and came about to start this startup, and also talk about the kind of problems we are solving at Godel Space, so that in the hope of motivating you or even showing you the possibilities that are out there for being entrepreneurs. So just to talk a little bit about my journey here, I had my undergraduate years back in India, where I was educated in computer science discipline. I learned a lot about parsers, learned a lot about formal systems. So if people are aware of axiomatic systems, where you define the rules, where you define axioms first and define the rules of inference, and then figure out how to create lemmas and theorems. Such was the formal systems that I worked with when I was at your age in my undergraduate years, and I got a chance to work on those formal systems. Four great years, and it taught me really how to think about problem solving. Then I came to the industry, and I 2 decades of experience in primarily software engineering and all kinds of roles: product manager, software engineer, engineering manager. I've seen from all vantage points. I've seen how to solve problems. And how to take from requirements to delivering productionized systems, right? And so that's what happened in those 2 decades, where I got the opportunity to build APIs, microservices in the cloud product, products used by millions of users, authentication problems, authorization problems, all the usual problems that everyone deals with every day. right? And we got a chance to build that in those 2 decades there. Then very recently, with the advent of AI, a lot of questions got answered, right? I'm a engineer at heart, and I used to have a lot of gaps in understanding what a startup is all about and what it takes to build a business around it. Because an engineer's mind is very different from building a business model around a certain idea. So, but with the advent of AI, the point being that AI helped bridge certain gaps and answered a lot of questions, because of which I was able to, a few of us got together and we thought of solving a small problem on the fly. And that was, we call it Safe Edge. And the idea behind that was content moderation. We took a real world problem where there was a lot of pain around online communities where people talk. And when people comment about what is happening online, they leave very bad remarks and comments, which affects a lot of people. And it's both in talk, it's both in leaving comments, and we quickly build some AI models that will moderate the conversation, meaning they will listen to the conversation and it'll moderate certain words and classify it as a certain category so that the exact words are not sent over, which gives a bit of a control in how the conversation goes. It does some sentiment analysis. The models run on the edge device, low power, small models, fine-tuned with llama kind of models, and into a small digital models which can be deployed onto the edge. So that's what we did at Safe Edge, and interestingly, we got a good response to that, and we were awarded some prize as well. But the point of all of that being that we had a number of tools at our disposal, which are very much available to all of you. It's just about connecting the dots in the right way. And because of the success, I was able to take the leap and start my own startup called Godel Space. That happened in 2024. And I personally wanted to solve a real world problem in the space and the geospatial industry, which affects a lot of people, which is a pain point for a lot of people. And I wanted to really apply AI to satellite imagery. That's where my heart lied. And it's also impacted a lot of people. So that's the problem I selected to solve. So that's the overarching broad stroke of my journey. And I just briefly wanted you to know that just like you have a great campus here and great opportunity to access the resources, the great minds of your friends and professors that you have here. Similarly, I was fortunate to be a part of one of the universities in India. And this is, you can read the statistics there. I'm not going to read that. But it was a beautiful campus. And we spent 4 years there in my undergraduate years. And one interesting statistic is this was back in late 90s. That is when I attended my university. And one funny statistic that I shared with the people is internet connections in those days were just coming along. And it was a Web 2.0 era that was just starting, just like Web 3.0 is starting for us right now. And we used to have 500 kbps internet connections, and we used to go to the lab, put it for download, a small page, used to attend the classes and come back and read it. So such was the days in which we started with, and now there are supercomputers that simulate digital twins of the Earth and even the biological ecosystems. So it's a long way we came from those years. So I just wanted you to know about our university there. So taking it full circle, why did I mention about all that is the concept you study in your universities, it's very important. You get inspired by them, meaning you have to find out what inspires you. And for me, even though there are so many things that I learned in my undergraduate years, one thing that stuck with me is Godel's incompleteness theorems. This is the person this is the mathematician and we can call him a scientist too, that inspired me a lot because of his work. So his work involved those two incompleteness theorems, which is the first one and the second one. And they talk about formal systems. Formal systems are nothing but a fancy way of saying you have axioms, you have rules of inference, and you create theorems from that, right? It's usual stuff that you all study here as well. But what he proved is that in any sufficiently complex formal system, like arithmetic, with simple pluses and minuses and divisions and multiplications, that is enough complicated formal system. And he proved that if you take a reasonably complicated formal system, there are certain truths in that system that cannot be proved. So this person has separated the truth from provability. Proof is separate, truth is separate. And he divided those two concepts, and he proved that in a system, there will always be truths which could not be provable from inside the system. So that left a very, what do you call, a big impression on my mind, and that stayed with me. It seems to be a fundamental limitation of this universe that about the truth and the probability of any formal system, which tells you that things are not as they seem. There is limitation around it. And he used that statement there, the G equal to this statement is not provable within the system. That is the construction he used to prove his work. And it's as you can see, it's a self-referencing statement, which has a lot of certain properties which will help us, which basically is the underlying construction of these two theorems. So how is this related to all the work that I'm doing? As I said, this is what inspired me to realize that formal systems have limitations. When you build ground up systems from first principles, there are always some limitations, and you should take the observation approach where you constantly observe things and constantly update your models with the dynamic information that you see from the satellite or when you observe the Earth. So when you're observing the Earth, you have dynamic information about both the spatial aspects of it and the temporal aspects of it, and you constantly update your models. And that is a better way of approaching than building physics-related models from first principles. That's the intuition I had, and that's the motivation behind what I'm doing right now. And so far, we have these capabilities that we are currently building in our product, which is port monitoring by looking at the satellite imagery. There is a bunch of satellites that move around, and they take both spatial and temporal images of it, and using various kinds of sensors. As you all know, there is electromagnetic spectrum, and there is radars, lidars, visible spectrum, magnetic spectrum, and acoustic, thermal. There is a whole range in that, and there are various sensors to capture all that imagery. And our intent is to build models that will understand port monitoring and will understand orbit debris. There is a lot of debris in the orbits, and we want to monitor all of it. So that the satellites and other objects in the orbit, they become autonomous, so that they can take their own decisions when they see a certain debris, or if the camera is pointed to the Earth. Right now, we are building models for port monitoring that will help with the traffic in the port, the number of ships entering and leaving the port, the containers on the ship. By looking at the containers, we can also tell what's probably inside it based on certain restrictions. And such are the algorithms for the monitoring part of it. And lastly, we just talked about port monitoring and debris. In addition to that, we are also building a foundation model catalog where, where today it is, we have these two use cases, but there are many more use cases like deforestation, fire monitoring, right? Fires in the forest, infrastructure monitoring. And we can use this platform to fine tune your models to do each of these use cases. And that's what we are working on. So I will quickly try and demo this. So for the sake of this demo, I just built a quick, my team just built a quick app here. And let's say we want to detect the ships. And it's taking a bit of a time here. But the intent is here is to show you some satellite imagery, and then show you how the model detects certain objects, so that you can do some analysis around it. So I selected the ship detection, and let's say I have a video here. So this is what is called as the SAR data, synthetic aperture radar data, which is a good sensor to have on the satellite to capture images of the Earth, either during the night, even with the clouds and even with the winds. Even though the things are not clear, it has a good way of capturing the images on the Earth. This is not visible spectrum. This is called SAR, synthetic aperture radar. So as you can see, on the left-hand side is the sample image with the ships. And on the right-hand side is the bounded boxes that the model has predicted that it's a ship. And if we increase the confidence of the model, we see that it becomes even stricter as to what it can identify as a ship. But if we decrease the confidence, most of the objects are identified, and so on, right? So that's the nature of the application. Here is a second image, again, a port image, slightly in the visible spectrum. And you can see the bounding boxes on the right-hand side. The model has identified that there is a ship there. And again, this is still in progress. It all depends on the data we are training the model with, and so on. And this is a busy port, but it's essentially the same concept. Very quickly, I want you to show that this is the ship detection, and there is something called oil spills detection as well, where if you give this image, this is also a SAR image, and it's a spill in the ocean of the oil. And it on the right-hand side, the model has successfully detected that, yes, only that aspect of the shape, the contour, that's the spill, is the output of the model. And this is an even advanced part of it, because every pixel of the image is labeled as whether it is a spill or not. So earlier it was a bounding box, and now it is a segmented model. It's a segmented output, which means every pixel is classified as a spill or not. And such is the nature of these images here. Again, this is a leak. There is a leak in the ocean, and so on. So yeah, this is an app. I can share the link with Vikram, and you can play around. And so that is the demo of the application, a very small demo part of it. And lastly, I want to leave you with one thought that, just from your perspective, I just want you to leave this information with you, that from your perspective, if you're interested in this kind of work, and if this kind of work inspires you, what you should do is do some internships, with companies like Godel Space, or there are so many other people that talked before me that talked about their ventures. So partner with them. ask for a problem statement and see if that interests you and work on it. So that's one way of getting your feet wet with these kind of projects. Concepts, go beyond the concepts, just do a working project. And even in your university, you don't have to go very far to find a good problem. Your university might be solving some problem that is very relevant to the students. So just find and ask people as to what those are, and you can participate in that. And lastly, but not the least, hackathons are the best way to get involved for a weekend. Just participate, break things, see where things go. But in a weekend, you'll get to a good spot and you'll learn a lot of things. But that's the best way to learn and gain a lot of experience. So I think that's all I have for you all today. I hope this is informative, and these are my social contacts in case you want to be in touch. Thank you.
Did anyone have any questions for Vikash?
What we are doing is we are taking foundation models and training using our own data to fine-tune those models. I think we have used a couple of them here. One is YOLO, as you said, and the other one is Clay. Right? Yeah, CLA1. It is one of the geospatial foundation models, and it has a open source license, so that you can train and fine tune it with your own data. Yeah.
Any other final questions? Thank you.
All right.